Okay, Assalamu alaikum. This is our week 2 part 1 lecture. In this lecture I'm going to talk about VHDL programming, what is the difference between VHDL programming and other language programs that you learned. We already know C and we already know C++ and we know assembly. So what is the difference between VHDL and from where it all started? So our course learning outcome will be the development and test of VHDL programs. Keep in mind that VHDL will continue throughout the semester in the lab component. Now, our outline will be talking about hardware description language. What is a hardware description language? And then we will talk about ports and entities, architectures, processes, and their statements. Then the syntax of wait statement and comments. This is the topics that we are going to talk about on this part. Now, what is a hardware description language? A hardware description language is basically a language that is machine readable and human readable. If I give you a code in HDL, then you can read it and the computer or the machine can read it easily. So this language is not like C or C++, it's even a higher level language when compared to these other languages. So it's readable texts. It has readable text. So HDL is precise and can thus be automatically simulated to see exactly how an IC is supposed to behave. So it's mostly about behavior. So you'll see when we talk about programming, we need to program the behavior of the IC. So if I say an AND gate, what is the behavior of an AND gate? If I say an OR gate, how do we describe the behavior of an AND gate? Then we are going to talk about the simulation. Simulation is the procedure where within a tool known as a simulator automatically generates the output files. Why do we need to simulate? Why is simulation very important when it comes to hardware design? Before we start working on our system, we need to make sure that our system is simulated. Now, when we talk about simulation, this means that our hardware is... So when we talk about simulation of a hardware, it's a very important thing, because when you want to simulate your hardware, this means that you are not producing the actual hardware. Producing the actual hardware is very expensive. So before going to that expensive part, we go and do simulation. Make sure that our system works fine. Then we go for hardware. Now, in semester 2, we are going to talk more about these things, but mainly when we talk about producing an IC can cost you, one IC can cost you up to $50,000 just to produce the first prototype. Now, producing the first prototype for $50,000 is very expensive. So before producing and going to that expensive step, we go for simulation. So we need to simulate our system to make sure that the system will behave in the right way as it is intended. Furthermore, what is VHDL stand for? So V, okay, HDL is hardware description language. V stands for very high speed integrated circuits. So if you want to put the name in full, it's very high speed integrated circuit hardware description language, VHDL. But instead of saying VHSIC HDL, then it's a very long name, so we call it VHDL. So V is the short for very high speed integrated circuits. This was a project for the DOD, US DOD, which is the Department of Defense, and it was in the 80s. So they started thinking, can we program the ICs in a very high level language which is easy for everyone? So they said, okay, let's start on it. So the DOD assembled a group of people, scientists, with different backgrounds and asked them to come up with a language. So they came up with the HDL or VHDL, and it had its own syntax, which is very similar to programming any software. Next up, in 1987, the Institute of Electrical and Electronic Engineers, they said we are going to use VHDL as the standard for programming ICs, and the standard is called 1076. Now, why is IEEE, or what is IEEE? Now, IEEE, as you all know by now, is the Institute of Electrical and Electronic Engineers. They have their standards. So when you go and buy a phone, they will say it has Wi-Fi. It will tell you that it has Wi-Fi 6 or supports Wi-Fi 6, or it has the 802.1 standard for communication, which is an IEEE standards. All of these are standards from IEEE. Why do we need standards? If we don't have standards, then things will become very difficult to deal with. So having VHDL became a standard. This meant that companies creating VHDL simulators, in principle, will have a single clear language to support. Imagine that C++ was not a standard, and everyone will write the code in a different syntax. Different syntax mean everyone will have their own different ways to deal with the program. So we will have millions and millions of languages. So the same idea, it's a programming language. Let's say that every country will have their own language. We will end up with 300, 400 common languages. Instead, we have very common languages like Arabic, English. These are common languages. So it is easy to deal with and people communicate together. Now, there are three popular HDLs in the market. We have the VHDL, Verilog, and System C. Most of them, they deal the same. The FPGAs, the field programmable gate arrays, which we are going to talk about it in the next semester in embedded system design. The FPGAs is an out-of-shelf IC which can be programmed using VHDL. Actually, in the lab, we have the Cyclone VHDLs. I already uploaded for you a video for how to install Quartz, which will be used in the lab. So hopefully, if you see that video, follow the lab manual, things should be fine. Now, entities and ports. What is an entity? What is an entity? An entity is, in Arabic, I will say it, kaynuna. It's something, okay? So when you define an object, you need to define its entity and its ports. So I have a box, okay? This is my entity. I will call this entity AND gate. So what are the ports? It will have two ports, two inputs and one output. Now this is my entity, okay? This is my entity. On the other hand, what is inside here is our behavior, which we are going to talk about later. Now, we define a new component in VHDL by defining its design entity. Okay, a design entity is the main hardware abstraction of VHDL. Abstraction اللي هو اختصار. When you look at the component, when I see a component like this is an AND gate. I know it's an AND gate, right? What is the behavior? What is the port? I know the entity. Now this is our AND gate. This is our AND gate. What it does is something else. But as an entity, I know this as an AND gate. It has two inputs and one output. So the first part, when designing an entity, is the entity declaration. I need to name it. You need to give your entity a name. Few things you need to remember. I'm going to talk about them in details. When giving names, it's very important not to use preserved words. It's very important to name your entity the same name as your project when you're working in the lab. The second is you give it the body. You need to give for that entity a body, define its ports. Now, figure 1.1, which is this figure, give us examples of different types of entities. This is the entity of AND2. Of course, we don't use AND. AND is a preserved word. So we use AND2 or AND gate, whatever. So entity AND2 is, so this is how we define it. Entity, this is a preserved name, sorry, this is the name that we give. These are all preserved. Is, then port, define the ports. X is an input here. Y is an input also here. F is an output. Now, all of these three are of type standard logic. Okay, all of these three are of type standard logic. What do we mean by standard logic? It's the type that we are using for digital circuits. So we need to specify, when we specify the port, we need to say the name of the input, the type of the input, and what signal it is carrying. So X, two dots, it's an input port and of type standard logic. Y, two dots, is an input port of type standard logic. F, two dots, is an output port of type standard logic. Once you start an entity, you end the entity. Always entity with end entity. You give it a name, AND2, you end AND2. You put a semicolon here. The only statement without semicolon is this statement. Same applies for all other entities because they have all the same syntax. Just notice here, the inverter, it has one input and one output. So it has X and F as the outputs. So the entity inputs and outputs known as ports appear in the list contained between the brackets as shown here. Okay, semicolon separates each port. Note that the last port is not followed by a semicolon. Each port consists of the name, direction, and type. Name, it was, in our example, it was X. Direction, it was N. Type, it was standard std underscore logic. Okay, so these are the information that you always need to keep track on. So all ports are of type standard logic, which at this point can be thought as a simple bit type that can have the values of zeros and ones. No need to worry much about it. So we can declare the ports, instead of doing it like this, you can say here it is X, comma, Y, 2.N standard logic. So you can combine all the inputs together and all the outputs together. Okay, so it will be much more easier when you work with the ports. Now, when it comes to naming, you need to be a little bit careful. Okay, so first of all, VHDL reserved words are entity, is, port, in, out, end. These are all reserved words. You cannot use them. Just a simple rule: if you are typing and the word appears in blue, then it's a reserved word and you cannot use it as a name. Okay, when we are working with VHDL, if a word comes in blue, then it is this word you cannot use it. If I open here or keep it in, I will show you in second part. In the second part, I will show you this. I will open the program and show you. Now, the user-defined names must start. Sorry, user-defined name identifiers are used to describe parts of the design. So, like here, it is AND2 or 2 inverter. Okay, so user start words must start with a letter, optionally followed by a sequence of letters, numbers, underscore, characters, with restrictions with 2 underscores cannot appear in a row and an underscore cannot be the last character. Yani, you cannot use 2 underscores in a row after each other. You cannot end up with an underscore. You cannot say and underscore. Okay, so these are some restrictions. Some valid names that we can use: a x dot hello is fine. jxyz b14 sign wire underscore 32 index underscore counter underscore ini entity test. Some invalid names: n, this is a reserved word, you cannot use it. Wire underscore, it ends with an underscore. Wire two underscores in a row, you cannot use them. Okay, this is wrong. 4 multiplied by 1 max is wrong, you cannot start with a number. And underscore in 4, you cannot start with an underscore. These are common things. Just make your life simple. Start with always letters, don't start with a number. Use 1 underscore, never use 2 underscores, never end with an underscore. This makes your life quite simple and easy. So I will stop here. In the second part, I'm going to talk about this example and finish up with the first part of VHDL class. Thank you.